That was a great question from Daniel, and which maybe Luke had trouble answering. But the good thing is maybe Daniel can answer his own question, because he's going to come up on stage now. He's our next keynote speaker. Daniel's from Picnic, Daniel Gebler, and Daniel holds a PhD in computer science and an MBA. He's published papers, edited journals, chaired international workshops and on software correctness. He was director of R&D at Fred Hopper, and he's now CTO of Picnic, the world's fastest growing online grocery store that makes grocery shopping fun, simple, and affordable for everyone. We've all probably seen those little cars, vans driving around everywhere. But today he's going to get to the crux of what this event is about. This conference is about building the future of technology with engineering-led innovation. Can I please have a very warm Signal 2025 welcome, Daniel Gebler. Over to you, Daniel.
Thank you.
Yours.
Thanks a lot for having me. So I'm Daniel, CTO of Picnic, and indeed we have a mission to make grocery shopping simple, fun, and affordable for everyone. So our story itself is now already actually a 10-year story, and I want to talk a little bit about what we have done, how we have built the organization, how we have built our tech stack, but especially also the kind of the trends that we are seeing now and how tech will actually shape the next 10 years. And that is something which obviously we don't know exactly, but at least I want to share a little bit on what we see as trends and how we prepare ourselves. Yeah. So if you know a little bit of Picnic, then and if you have tried it or if you want to try it, then you will see obviously those kind of cars on the road. We have by now around 3,500 cars here in Netherlands, similar amount in Germany. So the operation itself has actually grown quite a bit. And the starting point, and this is something which is, I think, especially important when you're building tech, is that you need to come up first with, we were hearing already about business architecture, with a simple proposition. Because in essence, if you keep the business architecture, the business proposition simple, then it can be translated in a relatively simple software architecture, and then also building out the systems can be pretty straightforward. So the starting point for us was that we said, there are kind of three problems, or we observed three problems, why nobody was actually at scale shopping for food online. It was too expensive, people had to wait, and everybody was using basically an interface, the app, that worked very well for non-food, basically for electronics, books, and fashion, but didn't work very well for food. And the reason for this is also pretty straightforward. If you think a bit about how we all are shopping at Coolblue or Bol for typically 2-3 items, because you don't buy more at those shops, is very different than you buy for food. So for food, for instance, you know pretty well what is a banana, you know what is the cheese. And even more, what you're buying this week is 70-80% of what you buy this week is actually the same as you bought last week. However hipster you eat, you will simply eat week over week the same stuff. So therefore, you need a different kind of interface. And when I'm talking about Picnic, then actually we have kind of a couple of systems built. By now we have a team of 350 engineers. There's around 100 different applications that we're deploying. But in essence, these are kind of three technical pillars. One thing is our shopping app. This is, if you're a Picnic customer, you know this. If not, then basically just give it a try. But this is only a very small part of the tech stack. So the biggest thing what such a business is building is our logistical systems. So there are systems that are forecasting how many orders we need the next day, that are buying the systems, that are making basically the entire fulfillment process in distribution centers, fulfillment center happening, that are basically planning the last mile, and even more that are planning around 20,000 people by now. So this is obviously quite a stack that we have built. In the beginning, we didn't build it all ourselves. So our methodology was what many of you are also trying. You start with a third-party system. You're starting with a kind of platform. And at some point, when you know enough, when you're convinced what you need to build yourself, then you can do it yourself. So that is basically the way how we have started this step by step. And the really interesting thing, what, let's say, methodology-wise, what we learned is, if you're building technology, then obviously a project takes sometimes a while. So when we're building an automated fulfillment center, that is a project where we need to build this for 2, 3, 4 years. So there's a lot of kind of physical building to be a physical building that we need to do. There's the robot software. There's kind of a software that is in the warehouse planning the totes and many, many other things. So basically what you do there is you're building actually a software system that goes live in 2, 3 years, which was always the case. But in a world that is evolving extremely fast, you need to think a bit about when you're building now and designing now a system that goes live in 3 years, what is actually the technology that exists in 3 years? What are the technology components that you can using in 2 or 3 years when you finish your system? So this is something what became especially important for instance, in our fulfillment centers when we were looking in Vision AI. When we started, our first fulfillment center went in 2020 live. We designed it in 2017. Vision AI was actually at a de facto non-usable state in 27. So you could count items, but really recognizing items that were not properly placed in a tote were not going so well. In 2020, the technology was so well that actually we had to completely revamp that part already at the point of the start. So that is maybe one of the lessons that I want to share with you. That is something which hopefully many of you can avoid. So the interesting thing is, obviously, if you're thinking a bit about what are the core building blocks that you need to take into account. For us, this was personalization. And personalization means what do we offer to our customers? So the first thing is, which kind of products should we actually offer to our customers? And here we're going to the aspect of business architecture, business organization. If you don't know exactly what you need to build for your customers, then there's a very simple solution to that. Just ask your customers, co-create the service. And that meant for us a very simple approach. If we are taking the entire supermarket landscape in Netherlands, then you have 18 supermarkets. If you basically map out all the items that all supermarkets are offering, then these are 3,000 in common. But we all know that in a normal supermarket, you have around between 10 and 15,000 SKUs. So what we did is we started with the 3,000 SKUs and basically asked our customers what are the other 7, 8, 9,000 that we should also offer. So this was a kind of a starting point that helped us quite a bit to offer the right service to customers. But then the next thing is, if you're actually starting at scale to deliver to customers, you don't know exactly how well you're serving your customers. And you start in the beginning with customer service, but an interesting thing is at some point you can no longer, in a kind of a manual way, serve those kind of services. So here, natural language processing, a kind of a pre-LLM type of text approach to AI, helped us quite a bit to really understand what customers were asking for, also which kind of issues they were reporting. And that is something where you can get very quickly then insights from. But we heard already from Luc that there's a lot of LLM and AI technology going on. So the way how we are now applying this is a very interesting use case, which you should also think about in your business. So what we do is, we get a lot of descriptions from our customers about new products. Week over week, we are changing 3 to 5% of the assortment. Very common case in very common retail. By the way, I was very happy to see that retail has been scoring very well in your stats. Well, I have 2 takeaways from this. Very well on the software quality, very bad on security. So that is basically the retail one. But if you're looking to Gen AI, then obviously writing product descriptions, you can do based on the descriptions you get from your suppliers. What all of us are getting from our suppliers is text or product descriptions that are not good enough. That is clear. What has worked for us, and I encourage everybody to try it out, is make the following. Take the 5 best product or 10 best product descriptions that you have built yourself, feed this in a system like ChatGPT or Claude, and take that as an example, and say, build me based on a new product description that is based on those kind of 10 great examples. We are surprised how well this is working, and essentially, and now we can list basically semi-automatically completely new products. That means also in the way how search is evolving. So all of us are knowing, obviously, keyword-based search, and Google basically mainstreamed that already many years ago, and basically on all websites and web stores and app stores, you're using keyword search. But what is now happening is basically intent-based search. Intent-based search is not a new concept that many people have tried it already with semantic stemming beforehand. What is now possible, and this is actually really, really exciting, is that with the kind of LLM technology, you can in a very significant way build those kind of semantic searches where you can type in, I'm looking for a cake for my birthday, or I'm looking for a wine that pairs well with that kind of food. So this is something which has helped us quite a bit in actually really exploring a kind of a new customer base. And if you're looking now into what else can be done on the machine learning side, I will not talk just about machine learning, but I want to show a couple of examples that most recently have shaped a bit our product proposition. Is on the one hand recommendation. Recommendation is nothing new. Amazon has done this for many, many years. It's kind of a commoditized technology. But where it really helps by now is it helps also really shaping kind of new meals. So one thing what we have done, which is a very interesting thing, is if you take all the purchases of a customer from the last years, if you take a recipe database, for instance from the Alejandro or from BBC Food, and then you basically reverse engineer which kind of recipes the customer most likely has bought, then you basically match it with the latest recipes that you want to offer, and then create new recipes. A little bit kind of a complex approach, but if you do that, you can actually create pretty interesting new recipes that for 98% of the customers actually work really well. And that is something which is very specific to food retail, but I encourage everybody to experiment even a bit more with that type of approach, with that kind of technology, because this is really something which works pretty well. And if you look now, maybe one step further, what we are doing on the last mile. So basically, obviously, we need to deliver to customers. So what do we do when we are driving with our electronic vehicles to customers? Then also, a lot of data technology plays a role. I actually agree that database systems and data-driven systems are, from a software architecture, software quality perspective, a challenge. And we see exactly the same also on our side. But there is something very interesting what you can do here, and we have called it, this is not still a concept in development, a SODA architecture. SODA for software and data. So what you need to do there is essentially structurally think about what is the software architecture you're building, and we heard it already about also business architecture, but actually separately develop the data architecture or the data models that you want to model there. Obviously, everything needs to get together at some point, but in a world that is much more driven by data, by the analytics, but also by data that is coming from large language models, the real question you need to ask yourself, actually, is software architecture really the driving thing of your business, or should you start to think about data architecture? What we do now in Picnic, as a starting point when we have a new business idea, we design the data models. We are basically defining the data architecture, and afterwards we are actually designing the software system around it that is maintaining basically a life cycle of the underlying data models. This is something what is obviously a little bit simpler if you have a relatively young, fresh system, and this is probably harder to do if you have already a lot of legacy around you. But on the other hand, every kind of new service starts more or less from scratch. So therefore, it is definitely an opportunity you can think of. And you can have a really major impact with that approach. So one example I want to show is what we called our safety challenge. So the safety challenge is very straightforward. We have now around 5,000 cars on the road. We are driving every day around 500,000 kilometers, which with really young people, which means that there's certainly a challenge how to keep everybody safe. And even more, we are driving actually in family neighborhoods. So that means we need to think a bit about how do we help every driver to be as safe as possible. And the way as we are doing this is actually we are collecting obviously all kind of driving data. So how fast is somebody, accelerating and braking, how fast is somebody steering or using the steering wheel. Because what we know is if you are very fast, for instance, going left or going right, then obviously that is less safe than if you do this just very gentle. If you put this all together, then you can do basically two things. You can, on the one hand, start to give feedback, basically start scoring a ride. And the second thing is you can give this as feedback. So what we have done is we have built what we now call the driver score, a driver score and a driver coach, which means that every of our rider gets after a ride a score where you see how safe have you been riding and how well have you been, basically how safe have you been riding. And with that kind of driver score, you can do a lot. Because on the one hand, if you see that somebody is driving for an extended time not safe, then obviously you will no longer schedule him for work. But even more, you can think of interesting encouragements. So the one thing is, and these are the kind of the three main systems that we have built here. So one thing is the Run app, basically an app that we're using for our drivers. But what is even more interesting is the driver coach, where you see both a corner and a speed score. And a corner score is how well or how safe are you driving around corners. Some of you may have seen pictures where also picnic cars were flipping. That was a big issue in the early days. But that is only the reason why people are simply turning the wheel too fast. That has no longer happened for the last 3 years. And the other one is the speed score. The speed score is basically just measuring how fast is somebody going, how well he is in the boundaries. The biggest violation on the speed score was actually during COVID. Maybe just open question to the room. Has anybody an idea why could it be during COVID such an issue? Once again? Absolutely. The biggest challenge, the biggest protection from being too fast is having a lot of other cars on the road. And this is especially because we are obviously delivering in neighborhoods where there is quite a bit of traffic on the road. That makes quite a big difference. So the real question now is, if you're now taking that in, and if you're reflecting a bit about it, what is the real essence that such a system and such kind of a technology-driven innovation has driven? And there are kind of two things that I want to highlight. So the first one is that on the one hand, we have built all kind of software systems that are creating a lot of data. So these are kind of analytical, operational, but also reporting analytical data that we are storing in a data warehouse. There's obviously this debate going on between data warehouses, data lakes, share lakes, all kind of approaches. In the end, it doesn't matter so much. There are obviously differences. And there is stuff to be said about data warehouses versus data lakes. But in essence, the key thing, what you need to think about from a software architectural perspective, do you have a proper feedback loop that actually brings the data that is in a data lake or data warehouse back to an operational system? When we're designing a system, we are asking one key question, and the key question is, will the system perform better in a few days if you're not changing a line of code at all, by just having more data that it can automatically learn based on the past data? And that is some kind of a design principle that has served us very well, especially around the logistics. Because if you feedback, for instance, which kind of driving behavior leads to a faster or shorter or slower delivery, which to a safe or less safe delivery, then obviously you can make a system automatically improves the planning for the next day. Hence, it will be more safe. And that is something which we start to apply now also step by step to the consumer behavior, where you see our store, let's say, incrementally evolving. And that is something which is obviously a very interesting approach. But the conceptual or the structural difference that is happening in such a world is that we are moving from the classical kind of R&D type of software products to ML products. And I want to give, let's say, at least give a little bit of light on what is structurally changing there. Because in essence, this is not so much linked purely to all the discussions around large language models and AI, but this is more kind of moving from pure software products to software plus data products. So the first one is obviously all these products are using more and more real-time data. And that is pretty obvious. Many of you do this already in your systems. But what is pretty interesting is that those kind of systems are starting to no longer just be trained, maybe once per month or once per week, no longer just once per day, like all the recommender systems. You have kind of real-time training of those kind of systems. While you have in the past operational insights, now you have the insights from a model. While you do obviously all kind of A/B testing in the past, usually once per week or once per day, you have incremental testing and updating. But what is really very interesting is that what analysts can do with those kind of systems. Because in essence, in the past, an analyst was basically configuring and adding from outside kind of logic into it. By now, you have actually analysts, so these are kind of software and business analysts, that are starting to really drive the behavior of, to design the behavior of software systems. And what I mean by this is the following. We have, for instance, for our payment systems, we have seen all kind of behavior, consumer payment behavior, especially in Germany and France, where we are also operating. So what now is happening is that the switching between payment methods, integrating of new payment methods, is something which completely business teams can do based on those kind of ML models, because it's just a new connector that can be automatically be deployed. So what is the current state in general of the kind of the industry for this kind of ML learning. And we heard it already from Luke a bit. We have obviously this kind of perception that AI-assisted coding will, or perception to some extent also a trend, will change quite a bit in the way how we are building software. And there's no doubt about it. The perception that some senior leaders, that some, let's say that the industry sometimes conveys is that with tools like Lovable and others, you can, with just a simple prompt, generate a large part of your code base. And then sometimes the narrative is mentioned that you get already an 80% good enough solution. But there is a big flaw in that kind of line of thinking. The solution that you get is indeed 80%, maybe complete. If you look a bit into what you've created versus what is the change set that you need to put on top. But there's a significant effort that developers need to apply in order to understand the code that has the 80% that has been written in order to develop the remaining 20%. So in essence, from a time perspective, and we have applied that at quite some extent by now on Picnic, at a time perspective, it's for sure not 80%. And then obviously people are saying, well, Daniel, this is just the current state, just wait a few months and then it will be much better. Maybe, but I think all of you should just be aware that while those kind of AI systems are generating quite a bit of good code, and indeed, if you look to kind of metrics like PRs per dev or something like that, it is certainly an increase. If the impact, the actual impact is increasing, is still out there. And I can say for Picnic itself, we haven't seen an increase of the pull requests per developer. The outcome, basically the real value that developers are creating, has not increased in a significant way. So this is still something which we will closely monitor further. But one maybe interesting perspective for everybody to take into account is a very interesting one, where if you think a bit about all those kind of, do we need at all developers, or is a kind of code written at some point completely automatic? One interesting perspective, think a bit about what is happening now already in a normal tech organization. There's already a lot of stuff that is happening in an automated way. So for instance, you have things like the linting. You have refaster from Google. So these are, if you have classical anti-patterns in code, they can be completely automated in an automatic way, be recovered. So this is not something what is new to the tech industry. This is something what we, for instance, in Picnic apply since 2018. Google has launched it already in 2013. So this is something which is certainly not something what, as an industry, we're totally new to. If you look a bit further, how this can go step by step, that obviously bug fixing is something which works relatively straightforward. So what we do already is, based on a significant, on a proper ticket description and the code that you have, you can actually create already a proposed bug fix. The problem is still, and this is something good to keep in mind, the review of a proposed piece of code that will fix a bug is actually quite a bit of effort. So usually, the big skill that our developers need to develop going forward is actually to become better readers. Writing of code will be something what systems will do at a very extensive way. What developers need to learn much more is how to very quickly read code, number one, and how to write prompts or those kind of queries like an analyst would do. So hence the profile will certainly, on the one hand, you will move a little bit up, I think move up was the terminology, in the way how you write your queries, and that is definitely more like an analyst, more like a C-level executive, where you really think from a business architecture perspective. But on the other hand, you need to learn even better to read the outcome from those kind of systems. So therefore, if you work with Lovable and you cannot read code, then you have absolutely nothing. You will not be able to use it in a meaningful way. So what does it mean in essence for, let's say, the way how we need to develop and educate our developers? So one thing is obviously, if you now have developers that are working with an AI system and that are just asking a prompt and get some form of response, then you will get very quickly stuck because you need to revise those kind of prompts. You need to iterate over the prompts. So the real kind of, let's say, the next step, what our developers need to learn, and in essence, not only developers, the entire organization is, how do you really develop this kind of co-creator mentality in the way how you work with those kind of AI tools. I like very much the term co-pilot, because in essence, this has already this philosophy of co-creation in it. But the real question is still, how do we, this is in essence, all of us know obviously or have heard about pair programming. This is nothing else than just the modern version of pair programming. But the question is, pair programming has never, in most organizations, really be deployed effectively at scale. But now, with AI tools, we have actually applied the same methodology, and we need to learn as organizations how to do this properly. So the real question now is, how do we help developers to get to that kind of state? How do we help developers to bridge, to go from the point that they just ask a kind of a question and then need a lot of time to understand the responses that we get there. And the main thing what we have actually learned there is that we have introduced days, AI-free days. So when you're starting in your organization, applying those kind of tools, the most important thing is make sure that everybody has still the craftsmanship to really understand how to read code, how to read, let's say, how to understand the response of those systems. And I want to spend maybe a few minutes now to just go a little bit over the kind of the potential. What does it mean if maybe in a few years more and more of those kind of systems will be written and will be designed by AI systems? So one thing is, we all know TDD, so test-driven development. But what does it mean actually when you can actually create completely from a test your code? Maybe the only iteration that we will do in the future is writing, let's say, updating the test, which is to some extent a prompt, and the code gets automatically regenerated. This is something which is already now working to some extent, and for those of you that are using especially Claude, you will see that this is already pretty well possible. But that means also developers need to develop a very different type of mindset. Usually, let's say, writing a unit test is an afterthought, is something what developers don't find too much exciting. This is maybe the new kind of skill set. Write unit tests, and everything else will follow. But that means also that refactoring itself becomes maybe a complete different kind of game. Because refactoring is something what you can auto-generate one or the other way. We have seen good examples. The result is maybe something what you may not like, but let me maybe give you a very interesting perspective. If writing code, just think a bit about it. Now we see, let's say, 10, 20% improvements. Let's assume that it's maybe 2x, 3x, 10x, maybe even 100x. If with 100x the productivity improves, then actually the code architecture that you have plays no longer a role. Because you can, whenever you have a new idea, build everything from scratch again. This is obviously not something what we will have tomorrow or next week, but this is something where we potentially can go into towards too. That means also that software quality is something which is becoming a real challenge, because in essence, the software quality will converge towards an average, because those systems are producing only, let's say, the average, the most common denominator of what other people have developed. So if you want to stand out from a software quality perspective, and that's obviously linking very well to what we have heard earlier as the report, you need to do significant work. You will not get it out of such a system, because you get basically the most average, the most agreeable solution. That means also that our developers need completely rethink the way how they are developing going forward. And the good thing, and this is something which I'm probably most excited about in this journey, top-level developers, and some of you are, or at least have some in your teams, is something what becomes most likely even more valuable instead of less valuable, how this is sometimes mentioned in the industry. But it means also that aspects like, for instance, security, that is now, we have heard, definitely too often not yet on a good level, becomes even a bigger issue. This is obviously not something what you have obviously all heard about it, but this is obviously something where we all need to take a really good look on how we actually keep security in a good shape. Which means here also that the ethical aspects of development, which means, for instance, if you build a system, for instance, for credit fraud or fraud protection, is something, if you auto-generate this, if you're no longer reviewing this in detail, you need to most likely apply kind of ethical concerns or ethical requirements as part of the data points that you apply. So this is certainly something very interesting.
Industry transformation, the key to success is developers, 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 developers.
I guess all of you have heard it. All of you have seen it. This is Steve. I think 1995 or so when they launched at some point Microsoft. But I think what we have now as a real opportunity here is that because, let's see, the accessibility of writing software gets even more broader, so more people can write software, not completely without software engineers, is that the ultimate goal that we wanted to actually have everybody being a software developer is now, 30 years later, actually achieved. And maybe just a few thoughts that what I wanted to share about the kind of the bigger topics that may come next. So everywhere, there's obviously a lot of discussion now about agentic AI, etc. This is something we have obviously we have also looked quite a bit into it. I actually my main take on most of the LM topics is there is little value of being a first or an early adopter. You want to be an earlier follower. You want to actually learn and understand a little bit on what you can do. But this kind of hype over the last kind of 2 years that everything needs to be AI, and all the kind of the CEOs that have sent out messages that AI everywhere needs to be applied is actually not super helpful for this kind of industry. It has inflated the expectation to the technology in a form that is close to impossible at some point to live up to. But what becomes actually a real reality is that multi-modal AI is something what is happening everywhere. So for us, for instance, it means that we can, based on the user queries, create actually an adaptation of the picture that you see as a consumer for a specific product. So this is now a search query-based adaptation of the images that you see for the specific type of product. So this is something where you really translate kind of a text query to the modality of video. You can do this also with audio. So this is very interesting. Obviously, voice has been a kind of a big topic for many years. People call this kind of the big revolution for retail. Has never happened. But the revolution is happening on logistics. So I would actually encourage everybody for things like voice, also to look a little bit into the unbeaten path, and especially the ones that are a bit more boring. Well, boring is the wrong term. Logistics is cool, but maybe more the parts that are a little bit less often matched. One thing what we see very often now, especially in our tech stack, is that many of the AI topics are moving much more to the edge. So what I was showing earlier about the kind of let's say the technology that we apply in our cars for safe driving, etc., is obviously classical AI. The same is happening now also in fulfillment centers, in distribution centers. We see this in many, many, many aspects where actually AI on edge is becoming the new standard. And the real question is, how do you also can make it scalable, and how can you apply it in the existing stack? Maybe one last thing. A few people are also talking about AGI. This is year 27 mentioned. Some people 39, 41, whatever. I think in reality, and we have been working with that technology for quite a while, I think in reality, we should be all realistic that there's quite a way to go. And we see already quite a bit of superhuman intelligence for all kind of things. But AGI, as kind of it has been envisioned, is definitely quite a way ago. And I encourage everybody to look more for the kind of the verticals where AI can really play a good role. And maybe 5 learnings, just to give a little bit of kind of a lessons learned from and a reflection on the way how we have done this in Picnic. Often, there's a tendency to work on this kind of cool, fancy stuff. But actually start with the easy things that are a bit more boring, but that give you a good edge to this. So for instance, if you want to start with machine learning, start with the classical kind of customer service ML optimization thing. Everybody has done it. This is pretty much a safe bet by now. This gives you quite a bit of learning on how you can do this. Testing in production is obviously something which we as developers don't like, but this is the only real way how to fast iterate. the only way how you can innovate is building cross-function teams. We have all heard it, but the cross-function means actually here it goes a little bit further. The cross-function is from a skill set perspective, but also from a seniority perspective. We saw this already earlier from Luke. This is something which is really, really, really important now. The development for models needs to be obviously be driven based on the impact, but especially the impact potential. And one thing what will never get out of fashion is actually talent. So looking for the best and the smartest people, and this means especially the analytical people, the people that can adjust, is something that will always serve you very well in that kind of transformation. This is something where sometimes we get the question, okay, how do you prepare for this kind of ML disruption? How do you prepare, where do you find the best ML or LM engineers? We don't. So what we do is very simple. We simply take people from a university and we build them up in the organization as we need it. And this is something which is something that I encourage everybody to at least consider. It has served us pretty well. That brings me to the end of the talk. Thanks for your attention.
Thank you. Wow. Wow. Thank you, Daniel. Thank you, Daniel. That was fascinating, wasn't it? Thank you for that insight into your company. Sounds like a fun place to work, is it?
It is.
Yeah.
Are you applying?
I have no skills to bring. I can drive a van, basically.
Also that.
Yeah. But is it a fun place? You sound very passionate.
Certainly. It's an amazing place. I think what is really exciting is that there's all kind of new challenges. Most of the stuff is working, a lot of stuff is not working, but if you have a kind of a culture that is also very understanding that not everything can work out, then you have also a lot of people that are willing and able to take a risk.
Okay, so you take risks, and sometimes you make mistakes along the way. Mm-hmm. What's the biggest leadership mistake you've made along the way that you've maybe learned a valuable lesson from?
That is a long list. I think I'm not even sure what let's say, if leadership mistake is maybe the most relevant one. So we tried all kind of things with customers where there was then rage. How could we change the app in that way? For instance, on the list where you see the previous orders and all kind of stuff. But I think one, let's say, the biggest thing what we really underestimated is preparing and architecting for scale early on. And we are here in let's say, in a tech environment. Everybody knows how difficult it is. So this kind of shift left is obviously we all know very well, but we have really underestimated how difficult, even in an agile environment, it is to really apply at scale this shift left. Early on, define a scalable and adaptable architecture that you can really open up for the next things. And for next things means, for instance, we started with food forward logistics. So you order your food, you get it to customers. You get it basically. And at some point, we just said, well, okay, maybe we can do a little bit more. Our cars go full to a customer, go empty back. So from a utilization perspective, it's only 50% used. Yeah. Let's use also the way back. So therefore, we introduced return logistics. If you order something over Zalando, you can send it back over Picnic. But that obviously changes completely the assumptions that we had in the beginning and required quite a bit of rework.
Right. So what would your advice be for a smaller company that maybe doesn't have your budget or scale, how to build a sort of a machine learning foundation from the start?
I think a lot what you need to do is you need to start experimenting, open up, basically allow everybody to experiment with the tools, but also communicate clearly to the organization. You need to still spend half of your time, 70, 80, whatever, on creating real business value. So there's obviously a bit of kind of the risks that you get carried away with all kind of experimentation. But to some extent, you need to also grow and need to build some real business. But if you are, especially if you are already reached some maturity level, if you get satisfied with that, then you're basically growing or going backwards in the industry, a bit like what we heard earlier. If you're not changing, then basically next year you will go in the rating one step back. And the same happens also in the industry.
Not going forwards, you're going backwards. I'd like to open it out for questions. We'd make this as interactive as possible. Anyone got a juicy question for Daniel? Nobody? Yes, one over there. Oh, there you go. Here you go. Give you the microphone.
Hi, I'm Alexandra. Thank you for this talk. I was wondering, for instance, with the driver-style app, there's of course also a lot of external systems, such as fleet management systems. How do you decide between building yourself or buying external systems?
It's an excellent question. So let me give you two answers to that. So most of the systems that we are now using, we had in external systems before. Because in essence, it is very difficult to really build a great system from scratch if you're not really an expert in this kind of domain. The second thing is what you typically buy from an external system is the least common denominator that the market has understood the problem, and that is something what you buy in. So that means you can only excel with a specific business function, like for instance route planning or last mile delivery, etc., if you can extend the system that you're buying. So when we looked into this kind of space, there was very limited kind of extension possibilities to the solutions in the market. We knew that this is for us a competitive advantage, hence we started to build it ourselves. The real capability that we all need as organizations build up is, if something gets commoditized over time, you also throw your own solution away and you use the standard solution from the market. So for us, this meant, for instance, WhatsApp was a very important channel for us. So WhatsApp became a kind of a public channel, or became a professional offering in 2018. So we used WhatsApp since 2015. So there was no real serious offering at that point in time. So we built a wrapper over the web interface of WhatsApp, such that we could use in our customer service environment WhatsApp. That worked actually until 2018 well, and by now there's all kind of pretty standard solutions for WhatsApp that you can buy from the market. So we threw our own solution away and took the commoditized version. And that is usually the second part, is something what most organizations have a very, very hard time, including also big organizations in the country, to really phase out the stuff that they have built by themselves, the typical sunken cost fallacy, to not stick too much with this kind of old stack.
Thank you, Daniel. One last question. You mentioned that the job of a developer is going to be using AI to create the code, and then developers just reading. Is going to be reading. Isn't that going to be a bit of a boring job for developers? aren't developers people who like to create stuff? And
Absolutely.
How are you going to attract people to those jobs?
The real question is, what is part of creation? If creation means essentially really writing every character of a line of a code line, then indeed that will change. That is most likely what you no longer do. But actually, if you ask an architect, is he creating a building? Is he involved in the creation process? He is. And he is not setting a single brick in the building. So in essence, we all will build more architects than actually the bricklayers of the past. Okay.
So it's still an interest. Oh, you're getting attacked there by a fly. All right. Thank you very much, Daniel. Daniel Gebler.
Thank you.
Cheers. Thank you. Thank you. Very nice having you. Thank you.